We are going to examine an important statement. And for those examination oriented, it's a Viva question also, which is asked very frequently in Viva and the theory also, short notes, etc. Why collagen is rich in proline and glycine also. So we are going to examine this. Why collagen is very rich in proline. Collagen, as you know, it is a very, very strong structure with a great tensile strength. Tendon का अगर आप देखो collagen, it has got 20 times more tensile strength compared to steel wire of the same diameter. So a number of factors are there. We are going to examine role of proline here. Now proline, as you all know, it is amino acid, not amino acid. We also call it amino acid because it has got a very distinctive feature. Its R group is part of a cyclic ring. You can see here, R group of proline is part of a cyclic ring. Whereas in all other amino acids, it is not part of a cyclic ring. It is linear. But only in proline, it is part of a cyclic ring. So what are the implications? Implications are that proline does not fit into the smooth helical structure. Smooth helical structure, which is present in a number of proteins, proline does not fit into that. It is also called a helix broker. Wherever proline is present, there will be a sharp bend in the polypeptide chain. Look at my finger movement. Sharp bend in the polypeptide chain. जहां proline होगा वहां sharp bend होगा. Now coming to collagen. Collagen comprises of three interwound polypeptide chains. I can show only two interwound polypeptide chain. There is a third also. And these chains show sharp bends, very tightly coiled. So sharp bends are there at a number of places. So jahan bhi bend hoga, proline will be present there. So proline ensures tight interwinding of the three polypeptide chains. One more point, proline can be converted to hydroxyproline. In this reaction, vitamin C is required. So hydroxyproline on one polypeptide chain, hydroxyproline on another polypeptide chain, they can always form a hydrogen bond. You know, wherever hydroxyl group is present, an additional hydrogen bond can be formed. So hydroxyproline, number of them and large number of hydrogen bonds are formed. And you people know hydrogen bonds are electrostatic bonds which are individually weak but collectively very strong. Now a question for you. Why in scurvy collagen structure becomes weak? You people know in scurvy, there is frequent bleeding from the gums, from other areas also, because the collagen present in the, I think, tunica media of the blood vessel, that becomes weak. Why it becomes weak? Try to find out the answer. Just a hint, because formation of hydroxyproline is decreased. One more amino acid which is present in abundance in collagen is the smallest amino acid, that is glycine. And as we had seen, glycine ke andar the R group is H. So it is the smallest amino acid. Now we also saw that tight intertwining of the three polypeptide chains is there. Therefore, very little space is available in the interior. And only the smallest amino acid, that is glycine, can be accommodated in the very little space available in the interior. So, in fact, every third amino acid in collagen is glycine. And supposing just a clinical correlate, if glycine were to be replaced by a bulkier amino acid, there is a mutation in a disease called osteogenesis imperfecta brittle bone syndrome. तो उसमें क्या होगा? Glycine is replaced by a bulkier amino acid. In fact, every amino acid is bulkier than glycine. तो I don't remember, I think it is alanine से होता है or whatever. Chalo, anyway, if there is a mutation, glycine is replaced by a bulkier amino acid. Bulkier amino acid cannot be accommodated in the limited space present in the interior. So therefore, the collagen, the tight intertwining is disrupted. Collagen becomes weak, brittle bone syndrome because the child suffers from frequent fractures because the bone collagen is weak now. So that's all about it. Find out what is the exact mutation in brittle bone syndrome. So that's all for this. Thank you so much.